Hello friends, welcome to my channel. Let's have a look at problem 473 together. Today's challenge problem, Matchsticks to square. So for this problem and in this video, we're going to share a method using backtracking. So the key assumptions in the problem is that we need to use all the matchsticks and use each of them exactly once. So this actually determines the format of recursion call in our solution. And as we use backtracking, essentially we try all the possibilities. So we can actually have a rough estimate of the number of configurations. So each of the matchstick should be put in one of the four edges. So each of the chopsticks have four choices. So the total number of matchsticks, let's call it n. So the number of configurations equals to 4 raised to the power n. So as in the constraint, the length of the matchstick is bounded above by 15. So this number of configuration is bounded by 4 to the power 15, which is nothing but 2 to the power 30. In other words, it's at a scale of million. So due to this number, so we need to use some memorization in the solution, and also some pruning might be helpful. We will use both the two. So with that said, let's look at the code. So first I'm going to track the length and the sum of the matchsticks. So we have changed the argument name matchsticks to capital M for ease of writing. So n is the length and s is the sum. First, I'm going to check if s is divisible by 4. If not, so we cannot make it. So if s modulo 4 is not 0, so we are going to return false. So this is the one edge case. Otherwise, each edge will have length s integer division by 4. Right. So as we mentioned, we are going to use memorization and pruning. So for the pruning, essentially I want to do a sort. So m sort. So basically we want to do it in a reverse order so that we can make the trial and error procedure much faster. So with that said, let's write the partition function. We want to partition all these matchsticks into 4 parts. Each belongs to one of the edge, and then we want to check if the edge are the same in length. So let's define this function as partition. So it accepts 5 variables, say L1, L2, L3, and L4. So these are the length of the 4 edges, and this is the index for which we are looking at the corresponding element in the matchstick M. So for this question, we are going to use some memorization. Let me use least recently used cache. So with that said, let's write the main logic in this function. First is a return condition. So if L1 equals L2 equals L3 equals L4 and equals the edge length required, we are going to return true. So another exit condition is that if we reached out of the index for the matchstick list, we are going to return. So if I equals n, we are going to return false. So with that said, we are going to look at the main logic. First is another stop condition. So if in the process we add an edge to either of the 4 edges, if it exceeds the desired length, that is edge, so we are going to return false. So if L1 greater than edge, or L2 greater than edge, or L3 greater than edge, or similarly L4 and greater than edge. So in this case, we're going to return false again. Then next basically is our recursive call. So we want to call this function partition. Then we can decide to add this current matchstick corresponding to index I to each of the 4 edges, right? So it's L1 plus mi, and just copy L2, L3, L4, and then I plus 1, right? Then we just need to copy all these cases. So here we add to the second edge. And then we add to the third edge. Or we add to the last edge. So if any of these 4 situations returns true, we are going to return true. So notice that we must use the matchstick I. So there's nothing like L1, L2, L3, L4, I plus 1, right? So that's about it for the hyperfunction or the backtracking function. So now let's look at the return. What we want to return is that we want to return the partition. So at the very beginning, each of the edge has length 0. This is the initialization, and we are going to start at index 0. So that's the full code for this solution. So let's do a special case check. So here, return partition 1. Let's see. Alright. Yeah, it passes the special case. Now let's do a generic case check. Oh yeah, it passes the generic case. So if we do not use the least recent used cache, or we do not use pruning by sorting here, so it might be get time limited. So with that said, I guess that's it for this problem. Thank you very much.